Welcome to the second video in this series, where we'll talk about the basic web structure. The World Wide Web as we know it is broken up into three abstract layers. The true size of each layer is impossible to obtain, but we do have some estimates to work with. The topmost layer is known as the surface web, and the websites here are what you see when performing a web search. To many people's surprise, the surface web makes up less than 10% of the entire web. Below the surface web is the deep web. Websites in this category either haven't been found by search engines like Google, or they've been found, but specifically asked at that time not to be included in search results. Thus, all websites in the deep web are not searchable unless you happen to know their exact URL, and many of them are password protected. Some examples of deep web pages include your bank account statements and classified government files. The deepest level of the web is known as the dark web. Most users will never go here, and that's probably for the best. Statista reports that only about 12% of web users have ever been to the dark web, and that figure falls to only 10% for users in the United States. The dark web is technically part of the deep web, but what sets it apart is that websites here go through extensive efforts to keep themselves and their users' data anonymous. Whistleblowers have made great use of this feature of the dark web. NBC, The Washington Post, and The Guardian are three well-known organizations that host secure drop information portals on the dark web. Two extremely high-profile dark web whistleblowers include Edward Snowden with his NSA surveillance leak, and Julian Assange with his publications on WikiLeaks. You may have already guessed that the dark web can be a pretty shady place, and you're right. The unregulated sale of firearms, drugs, and child pornography all find their home hidden on the dark web. Congratulations! You now know the basic structure of the web. That's all the information that you'll need to understand the next chapter, search engines. So if you just want a basic overview of everything, and you're ready, then head on to the next video. However, if you'd like to learn more about URLs, data transmission, and VPNs, keep watching. The following information is somewhat technical, but it's necessary in order to go any deeper. Alright, looks like you're sticking through it. To start this subsection off, let's talk about URLs. URL stands for Uniform Resource Locator, and everyone has seen a URL, regardless of if they know how it works. Here's an example of a URL. The first part of a URL is known as the connection protocol. Connection protocols tell computers how to send and receive information. On the web, this is typically either HTTP or HTTPS. HTTP stands for Hypertext Transfer Protocol, while the optional S stands for secure. Please note, a non-secured HTTP website isn't necessarily dangerous. It just means that you should never enter passwords or credit card information on it, as they would be easily readable in plain text during transmission. Depending on the browser you use, you may not see the letters HTTPS anywhere, but if you see a lock icon near the top, it means that your connection is secured. The second part of a URL is known as the host, or subdomain name, depending on who you ask. These names help point users towards a particular subsection of a company's main website server. For example, Google Docs uses Docs as its subdomain name, while Google Gmail uses Mail as its subdomain name. Some smaller websites don't need a subdomain name. The third part of a URL is the domain name, and this is the most memorable part of a URL. This name is used to look up the location address of where a particular website is stored around the globe, also known as its IP address. Note, there are typically hundreds of websites stored at any given web IP address. It's sort of like an apartment building. The fourth part of a URL is known as the top-level domain. Fun fact, it's possible to have two websites with the same domain name but different top-level domains. For example, hi.com and hi.edu. These top-level domains are supposed to help communicate what type of information each website wishes to convey. The final part of a URL is known as its file path. When you first load a website, chances are that you won't see any file path at first. However, once you click on a button, that will most likely change. For example, clicking on iPhone takes us to the iPhone subsection of apple.com, and clicking on Compare takes us to the Compare subsection of the iPhone subsection. In addition to clicking buttons, we can also manually change aspects of the URL to take us directly where we want to go. Changing iPhone to iPad will take us directly to the comparison site for iPads instead of iPhones. We can also delete the Compare file path to take us back to Apple's main iPad website. Alright, I know, that was a lot of information, but I promise that what we just covered will help greatly in understanding how web data transmission works behind the scenes. Ready? Let's see how it works. We'll use the web page https://support.apple.com/iPad for our example, and then pressing enter. First, my computer checks its local cache to see if I visited this website already. If I have, then I already have the IP address, and I can directly load the website without any further step. However, if the local search comes up negative, then it's time for a domain name system lookup, or DNS lookup for short. To do this, my computer creates a DNS packet. You can think of this packet as a mail envelope. The envelope has a destination address, a return address, and a letter inside that asks for the real IP address of apple.com, among other things. Now that my computer has created a DNS packet, it's time for it to leave my local area network, or LAN for short. My computer transmits the DNS packet to my Wi-Fi router, which forwards it to a modem, which then sends it out across the internet to my Internet Service Provider, or ISP for short. Upon receiving the DNS packet, my Internet Service Provider forwards it to a public DNS resolver. The resolver also checks if any other users have looked up Apple's IP address recently. If not, then the resolver forwards my DNS packet along to a root DNS server, changing the return address to itself. The root server begins by reading the fully qualified domain name that I provided in my DNS packet, backwards. The root server has a list of IP addresses that lead to top-level domain servers, or TLD servers, that match the ending of my URL. When the root server finds a match, it sends the IP address of this server back to my ISP's resolver. The resolver will open the DNS packet to read this new address, and then send it off to the new location. When the TLD server receives my packet, it looks through its list of authoritative name servers and randomly chooses one of their IP addresses to send back. All of these authoritative servers store the same information. The only reason for this process is to distribute the load of user requests across the system so a particular TLD server doesn't get overwhelmed. Now we're in the endgame. The authoritative name server receives my packet, reads the fully qualified domain name I provided, and then sends my packet back home with the IP address of Apple's website. The DNS lookup is complete. Upon receiving the IP address, my computer establishes a direct connection with the new server and loads Apple's website from it. And all of that happens in a couple of milliseconds. VPNs are a great way to increase privacy online, but I can't stress this enough. If you're using a free VPN, don't. Many popular free VPNs, including BetterNet and Hotspot Shield, have been accused of selling personal data. Many people use VPNs to get around company or school-blocked websites. This works because, while the corporation may be able to block direct access to Instagram, let's say, encrypted VPN traffic doesn't look like it's headed to Instagram. It just looks like it's headed to a random IP address on the internet. Admins can try to block connections to these IP addresses if they discover it's a VPN, but because each VPN provider has hundreds to thousands of unique IP connection points, there's simply no way to catch them all. Alright, that's it, I swear. The next 2 chapters are much less technical. So when you're ready, click on over there and learn how search engines decide what information gets shown and what information doesn't. See you then.